Hello YouTube. I was searching the internet to find the calibration and the service manual for this multimeter. It is a Mastech MS8222H. It has LX, capacitance, frequency counter, duty cycle, HFE. It's cheap but nice multimeter. Okay, the Chinese didn't reply to my emails about the service manual. Also, the Greek company that imports the multimeter in Greece is also for the festivals. Okay, they do not support any service manual or anything else. Okay, so there is only one way to reverse engineer it. So I went and did that, and here is the calibration manual I want to post to YouTube so other people with this multimeter can calibrate it. Okay, let's take it apart. This is the battery compartment. Okay, watch out about these screws. Okay, be careful not to lose them because there is no support, not at all. Okay, watch out for these screws. This is the battery compartment. Okay, what happened? Let me show you. This is another like this, the same multimeter. This is never opened. This is my old multimeter. I went and because I was in a hurry, I went and connected the battery the wrong way. Just contact on the contact of the battery the wrong way. The push button was on, okay, and smoke came out of the multimeter, the magic smoke. Okay, so that's why I wanted to find a service manual to fix it. I didn't find it. I found almost the same the diagram in the internet, reverse engineered it and fixed it. I fixed this multimeter, the old one. The new one is okay, and also because I replaced some components of the multimeter went out of calibration, so I needed to calibrate it. Okay, so I went and reverse engineered everything, and here it is. I'll show you in a real time. Okay, this is the multimeter. Okay, we take off the back cover, and there is no screws here. You just pull this PCB out. There is no need to unscrew anything because if you unscrew these screws, this is gonna fall off. Okay, let's see it now. We have, I hope you can see this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 pots. Okay, I blew up these capacitors in the other meter and this resistor, these transistors here. Okay, I fixed the other multimeter. Also, this is a little bit of calibration, but I want to have the same measurements to all of my multimeters. Okay, we are gonna use a trusted multimeter. This one, this is a very nice multimeter. Okay, it is 4.5 digits, I think. It's a Unity 71D. Okay, we are gonna use this for calibration. Also, power supply, a trusted scope and a trusted function generator. Okay, let's show here. Let's begin with the easy stuff. Okay, I hope you can see this. These are the pots here, and these are the 3 pots here. The easy stuff. This is a capacitance to all the ranges. Okay, this pot is to calibrate the capacitance, the range, all of this. These 3 pots, 1, 2, 3, is for inductance for this range. Okay, they are not independent, they depend on each other. You'll see later. We begin with the small scale, 2 millihenry. Okay, we adjust this, and then the next range, okay, and back, next back, you'll see. Okay, these 2 pots, this one, and this one is for the temperature. This is the low temperature, this is the high temperature. Okay, this pot here, this one is for the kilohertz. Okay, for the kilohertz range here, and for the duty cycle it's the same. Okay, this is the frequency adjustment. Okay, and this is the tricky stuff now. The tricky stuff is that those 2 pots, this one and this one, and they are not they depend each other. Okay, this one, the first one, this one is the reference, the voltage reference of the analog to digital converter, which is a microchip, a TC7106, okay, 7106. Okay, it's on the pins 43 and 44, and between these pins we have to calibrate this pot, this one, for 100 millivolts. With this multimeter we are going to do this. Okay, when we finish with this pot, then we move to this pot, this one, and calibrate, fine-tune, you can call it, for the voltage ranges and the amps ranges of the multimeter. Okay, let's begin. This is important. First, we have to remove the LCD like this. Okay. Oops, 100, and like this. Watch out for these 2 cables, is for the backlight of the LCD. Okay. Okay, here we are. This is the microchip. Okay, this is the microcontroller. This is the analog to digital converter. This is the microcontroller. Okay, and this is the pot. We are going to adjust on these 2 pins. I don't know if you can see. 43 and 44 is the last to the right in this side here. 43 and 44 pins. Let's move. Okay, battery is hooked up. We power up the meter. Okay, you are not going to see anything because the LCD is not connected. This is the flex cable, the rubber cable over here. Okay, let's measure the 2 pins. I probe the pins, and actually is 140 millivolts. Okay, I'm gonna adjust it with this spot to 100 spot on. Okay, Okay, let's move. Spot on. Done. The 3 over the right is the most the least significant digit. Okay, it's 100.02. Okay, 100. Let's move on. Done with this spot. Okay, LCD is back. Okay, and the voltage reference adjusted with this spot. Done. Next move, we're gonna adjust this spot. This is the balance for the AC voltage and current. Okay, and also I think also for the DC. Okay, this is the kilohertz range. Okay, the kilohertz, 20 kilohertz range. Okay, let's move. This is the power supply on the 5 volts rails. Okay, this is the fixed 5 volts for CMOS. From the power supply, the power supply is calibrated. It's spot on. 5 volts. Okay, let's see this multimeter now. This multimeter is $4.99. A little more. A little more. Done. Done with this pots for now. Okay, let's move to the kilohertz range. Okay, spot on. Okay, this is a function generator. We take from the TTL output. Okay, the sync output. And this is the scope. Okay, give me a moment. Media voltage off. Okay, this is 5 kilohertz. Okay, this agrees with the scope. This multimeter agrees with the scope. So I'm gonna use this. Okay. We are at 10.03 kilohertz. The scope agrees. Okay, 10.03, and this guy is a little bit off. Let's fix that. Done. Nice. Let's see now. 5.528, 5.53. Nice. Done with this. Next. Now we are going to calibrate the capacitance. This spot here. This capacitor is 144. Okay, let's put it here. Let's put it here. And also okay. This must be 144 spot on. Okay, let's see. This is the pot. Okay. $140. Okay, θα πάρει το resin. Six, spot on. Okay, let's put another one. This one is 2.2. Nice. This is a tantalum. Let's see. Yep, right. Ένα nano. 1 nano. Let's confirm it. Yes, 1.03. Zero 4. Done. 6 microfarad. Yep, that's right. Uh, 2.2. Yes, right. Well, I couldn't do this on camera because it's very tricky. With this pot, the fine tune you can call it, for the voltage and current, I gave exactly 50 Hz. I don't know if you can see this. And 61.8 61 millivolt. Okay, 61.8 true RMS millivolt. 61. I'm not going to do these 3 pots. Those are for inductance, because I don't have any other inductance meter. I trust this new one. This is a new one, and I calibrated the old one by this. Okay. Only for the last thing to do is to calibrate the temperature. Okay. Those two potentiometers, which is going to be the next one and the last one. Okay. This is the temperature. Okay, it's a little bit off. Let's fix this. Where the heck is it? Okay, 17.8 17.8 18. Okay. 17.8. This is 378. Also, this is okay, no need for calibration. The high temp. Okay. Oops. This one. Thanks for watching. See you the next time. Bye.